I'm Paulo Sozakiri, and this is my Charge Tapes lab report. So this lab had us experimenting charge using pieces of charge tape. Now charge is a fundamental property of matter, meaning that it cannot be created and it cannot be destroyed, it simply exists. This experiment also had us approximating quantum scale values, in this case excess charge, with low-tech methods. We also learned how to make somewhat reasonable assumptions about the physical world, and as you can see in this photo here, this is a quick little sneak peek at my results from my code. Now, the actual experiment here had us creating two pieces of charge tape and observing from what distance an interaction will occur. And in this case, actually, both pieces of tape will have the same magnitude of charge, so they will actually repel each other, same starting to charge. Now, to generate these pieces of tape, we would place one piece of tape on top of another piece of tape and quickly rip off the upper piece of tape, thus stealing electrons from the lower tape and having them get stuck on the upper tape, meaning that the upper tape has an excess negative charge. Now, to actually calculate the excess charge, we would record the distance at which the upper tape begins to levitate due to the lower tape. So we would get the distance between the initial position of the upper tape and the lower tape's position. Now, once the upper tape begins to float, according to Newton's law, that means it's actually in equilibrium, meaning that the gravitational field force is equal to the electrical field force. So we plug in that force value, because we know the mass of the tape, into the Coulomb equation, and we also plug in that distance. So as you can see here, we know K, we know F, we know R. These Q's are roughly equal because both tapes, we're making the assumption that both tapes have the same excess charge value. We solve for Q, and that's what the final result of this lab actually is. And in my case, I got a magnitude of excess charge of 1.867 times 10 to the negative 8 coulombs. Now, the system is basically everything you see in this figure down here, the two pieces of tape and the books. And the surroundings, everything else, like air molecules, table, things that we don't need to talk about. Now, the initial conditions, like I said, is when this lower tape, or this upper tape here, is just kind of hanging down, just kind of feeling the force of gravity, and that's about it. Now, I will also say that there were a bunch of assumptions that I briefly went into there. We treated these two as point charges, the two pieces of tape. We ignored air resistance, which is why it's part of the surroundings in this case. And we also assume that both pieces of tape have the same excess charge because they're roughly the same size. Now, that being said, these errors can lead to some issues with approximating values, but it's all good here. Now, here is my code from this lab. I actually decided to use dictionaries because I found that to be easiest for me to navigate the coding here. I plug in the value here of like the tape, and then I put the radius, charge, color, mass, and position, and then I repeat another dictionary entry for the upper tape. So the red dot here is the upper tape, the blue tape here, or the blue dot here is the lower tape. The red arrows are the electrical field force, and the green arrows are the gravitational field force. Now, the way I went about coding this was I took my experimentally determined value of the excess charge, and I kind of worked backwards to plot both the gravitational field forces and the electrical field forces using purely Coulomb's law and Newton's second law, force equals mass times acceleration. Now, if both the errors are equal, then that means my calculations were at least correct. That being said, not that the actual value of excess charge is correct, just that my calculations were. So down here, I iterate through the dictionary, I plot each particle for each entry, and then over here, I iterate through the dictionary inside of an iteration, so I can do superposition, adding all the electrical field values from all the other charges, excluding the one that was initially in this first iteration here. And then I go over here and I do F equals QE, and then I plot that force arrow, which is the red one for the electrical field. Now, for the conclusion, once again, I determined that the electrical field, or the excess electrical charge, was 1.867 times 10 to the negative 8 coulombs in magnitude. Now, what if electrons had a positive charge and protons had a negative charge? I would argue that no difference would occur in the observations, because as long as the electrons are getting snagged onto the tape, and as long as the excess charge has the same sign, then they're still going to repel each other the same amount. Now, why is it important to not handle charged tapes as much as possible? Because if you keep handling charged tapes, the excess electrons will leap off, and they will, lose that excess charge, and they will stop becoming reactive. That being said, you can't get them in contact too much, or else, they'll lose that charge.